our next speaker, the next talk is going to be runnable, scalable clusters on Oracle Cloud Infrastructure. And we are lucky to have today Marcin Zablocki, who's a Master Principal Solutions Architect in Oracle. He's the maintainer of Cluster Automation and HPC Imaging software. These are two products that are used by majority of HPC customers on Oracle Cloud. So I would welcome Marcin to give his talk, please.
Thank you for the introduction. Let me start the slides. I hope we can all see them.
Yes.
Yep. Perfect. My name's Marcin. I'm solution architect at Oracle Cloud Infrastructure. I've been at the high performance computing team for the past 3 years now. I am a maintainer of the cluster automation stack and solution, the marketplace for high performance computing, as well as high performance computing images running Oracle Linux on Oracle Cloud. In this tutorial, I'd like to talk a little bit about what Oracle Cloud is, since we see quite often that people ask questions, does Oracle have cloud, when we introduce ourselves. Then I will talk a little bit about our offering. What do we have for compute, for storage, some networking features that we have and that we are proud of. And we will switch to talk a little bit about automated deployment for HPC clusters. How does it work? How do you configure it? About autoscaling features. Why do we do them and how do we do them? And we will follow with some short demonstration of the features, of capabilities, and hopefully then I will have some time to answer questions. Of course, I will be available on Slack after presentation to answer any additional questions that might arise. So let's talk about Oracle Cloud and HPC journey for Oracle Cloud a little bit. Oracle, as most of you probably know, has been on the market for quite some time and invested in HPC from very beginning through various acquisition and purchases and its own development. So all started in '94 when we purchased the RDB division of digital equipment to run database products on the VAX and VMS computers. And then it definitely followed with 2010 acquisition of Sun Microsystems that I believe some people still hold grudge about for years. But that gave us access to the world-class hardware, the best what's in store for compute hardware, as well as 10% acquisition of Mellanox back then that gave Oracle access to InfiniBand technologies and high performance networking. Fast forward a couple years through, we're gonna skip the Oracle Cloud's first generation cloud. We'll leave it at that. But by 2016, Oracle decided to follow with the second generation cloud offering that started as bare metal cloud services and was shortly after renamed as Oracle Cloud Infrastructure, now mostly referred to as Oracle Cloud or OCI. Development of the new cloud offering progressed very quickly. We started with just one region, 3 data centers in Phoenix, offering only bare metal servers as a service, but virtual machines came very quickly. We started expanding our offering. By 2017, our first jump into HPC in the cloud showed up with our NVIDIA Pascal-based GPUs that followed next year with the V100 Volta offering from NVIDIA, very powerful servers. And in 2019, early 2019, we've launched our first RDMA offering for HPC in the cloud. Right now, we are constantly improving our stack. With the 2020, we launched the A100 offering, as well as new generation AMD CPUs. And this year, we had quite a few announcements, launching new Milan AMD-based machines, new Ice Lake offering, including RDMA shapes for Intel, and new ARM offering using Ampere Altra ARM CPUs. We believe that HPC is a strategic and very important part of our cloud business. We build everything with high performance in mind. We build also with hyperscale in mind, which means you get the best of both worlds. You get cloud infrastructure, API-driven compute, networking, storage services, all the platform services, databases, artificial intelligence services available in the click or console command, but running also bare metal servers with full access and very high performing. We run truly non-oversubscribed, fast and predictable network. What you see is what you get. If we say you can get 100 gigabit a second, you will get 100 gigabit a second, or next to it, 97. And we do have networking with 1 to 1.5 microsecond latency between the compute hosts, which allows to run all those latency sensitive, tightly coupled applications that you normally have to run in your own data centers on InfiniBand, and they will perform as good or even better. We have 36 regions deployed or being deployed as of now. Out of those, 14 contain our HPC and GPU offerings. So in 14 locations in the world, you can run high performance computing clusters or GPU based workloads, machine learning, any kind of artificial intelligence. Few regions also contain direct connection to our friends at Microsoft Azure, which allows you to connect both cloud environments if you run on both Azure and Oracle Cloud. With few clicks, you can connect your networks between the regions with very low latency between your environments. You can run workloads on both. You can run database on Oracle and application on Azure, or you can run HPC on both environments at the same time and have them exchange data. So why we believe we're better than the other cloud providers when it comes to HPC space. First of all, bare metal compute. We were the first one to offer bare metal compute. We believe we have the most experience when it comes to running bare metal servers, and they are true bare metal. There is no hypervisor, no lightweight virtualization anywhere except virtualized network that it's performed out of the actual server. So you get full access to hardware. theoretically, you could reflash firmware on network interfaces and do whatever you want to do as close to metal as possible. We make sure that those machines get fully cleaned up, fully wiped. We reflash everything. We military grade wiped all the disks after operation is completed, after you return the server to us. And it's all done in full cloud mode. You pay for what you use, no commitments. You want to run the server for an hour, that's fine. You will pay for an hour. We believe we have a better price performance ratio than our competitors. Our prices are generally lower than most of the cloud competition on the market, and with the bare metal offering, you don't get any performance impact. And it's very close to what you can get on premises. You run the servers as you would normally do. We just provide you an operating system and a hardware, or you can bring your own custom operating system if you wish to do so. We have shapes with more NVMe, local NVMe storage than anybody else. So if you really need this ultra high performance storage available, here it is, available in a click. Our block storage that we will talk a little bit later on delivers millions of IOPS at the lowest cost, and the cost is predictable. There is no crazy discovery of extra charges when you run it. And we've built the fastest file systems in the cloud that are ranked on IO 500. And the network. Again, the non-oversubscribed flat 100 gigabit per second network. Depending on the shape, obviously, you're limited to what network interfaces are available for the shape. Some shapes are coming with 25 gigabit interfaces, some with 50, some with 100. But you can run the maximum throughput from those interfaces. We do offer network performance SLA. So you can check our SLA tables, but we guarantee that your performance will be greater than 90% of published performance, 99% of the time. And we will pay you back if it's not happening. And the RDMA networking. It's a 100 gigabit RDMA network, Rocky V2, with ultra low latency that goes as slow as 1.5 microseconds. And we'll talk a little bit more about how we do it a little bit in a moment. But also, why would you shift from your on-premise environment to Oracle Cloud? Well, you can get the latest offering without capital investments. So if you need to run the latest generation of CPUs or GPUs, here we are to serve. We eliminate the refresh cycle. You just want to switch, you can switch anytime you want. And there is no loss of performance. You always get the latest. We really are, you pay for what you use, right? So you can scale your workloads depending on your needs, manage your cost more effectively, and select the correct hardware for the correct task at the correct scale at the correct time. And our business model operates on what we call cloud credits. You purchase a certain amount of cloud credits from us, and you can spend them on all Oracle services that you want. So you're not locked at spending a certain amount for compute or a certain amount for storage and networking. If you buy $1,000 of Oracle credits, you can spend them on all of those services depending on your actual use case at the moment. And the obvious, right? No managing data centers, electricity bills, power. You can focus on what you know best, which is running high performance computing. So what do we offer for compute? We do have bare metal machines, as I mentioned before, direct access, no hypervisor. You get your server for yourself. There is nobody else on it. You don't get the noisy neighbor, no performance loss, no jitter. You get full performance of your machine that you control. We also offer virtual machines for any kind of workloads that you might run on them. They are multi-tenant VMs with lightweight hypervisor. There is no much performance impact from running virtual machines. For networking, you get full access to hardware through SRIOV. So the network interfaces are directly exposed to you. But if you have some crazy old operating system that you'd like to run, we do also offer emulated virtual machine technology where all hardware is fully virtualized. You can run with emulated ID disk with the old GA card, reported VGA card, and Intel E1000 driver-based interface. So it's perfect if you have a DOS application that you need to run, you can do so. And we also offer a dedicated virtual machine host. And it's kind of the best of two worlds. We give you a bare metal machine with our hypervisor on top. You don't get anybody else. You get those machines dedicated to you. So they are single tenant. They provide full isolation from all other potential customers that normally would be your neighbor inside the virtual machine. Currently, we have 4 main offerings for our bare metal compute. We do have Intel-based shapes. We currently, for high-performance computing, specifically for high performance computing, we do offer 2, the bare metal optimized 3 and bare metal HPC 2. They are Skylake and Ice Lake generation, fast CPU, 3.6, 3.7 gigahertz all-core turbo, 500 or 384 gigabytes of RAM, local NVMe storage for your MPI checkpoints and data storage, and 100 gig RDMA interface attached to it. For non-tightly coupled workloads, we quite often suggest customers to run on AMD due to the high core density. If you have a smaller open foam model as well, it's sometimes easier to just cram it into a 128 core machine than run distributed across multiple nodes. They do come with the 2 50 gig NICs for communication, accessing the storage, and 2 terabytes RAM each. So these are beasts of machines, and they can handle quite well. There's a new thing for us, Ampere-based ARM instances with 160 cores, 3 gigahertz core clock, 1 terabyte of RAM. They are great, cost-effective, and we see an amazing performance in certain workloads for running on ARM. It's really impressive what you can do at the 1 cent per core hour. And obviously, we do have an NVIDIA offering. The latest on the market for us is bare metal GPU 4.8, which is 8 NVIDIA A100 cards with 2 terabytes of RAM, with 27 terabytes of local NVMe storage and 16 100 gig RDMA interfaces. So you can get 1.6 terabit network communication speed between the nodes. These are true deep learning power horses. It's unbeatable performance at fairly low price. These are $3.05 a GPU hour. You pay for what you use, and you get a lot for the money. For virtual machines, we came also with the new flexible shapes. We do offer fully configurable virtual machines where you can select amount of cores and amount of RAM independently for your workload. If your workload is memory intensive but not very core intensive, CPU intensive, you can do so. We offer this on Intel, AMD, and ARM. You can go on Intel, you can go from 1 to 256 gigs of RAM per VM, and from 1 to 18 cores. For AMD, it's from 1 gig to 1 terabyte of memory, and up to 64 cores per virtual machine. And for ARM, you can go up to 80 cores and 512 gigs of RAM. Cluster network. Currently, we offer 20,000 cores per cluster deployments. We don't see many use cases where people would deploy a larger single-use clusters in the cloud. 20,000 cores seems like a lot per workload at this moment, but we don't say we won't go higher. It's using RDMA over Converged Ethernet, Rocky V2 that gets low latency, 1.5 microseconds, 100 gig. We place the nodes in a single blocks of the data center, so all the nodes are next to each other. When you deploy what we call a cluster network, which is a pool of servers connected with RDMA. You get predictable performance. There is no oversubscription. Nobody's going to use your bandwidth. You can use full 100 gigs wherever you want. It's perfect for all CFD, crash, seismic, DNA sequencing workloads. We see an amazing performance reports from our customers and even from our own benchmarking. I do not have slides about that, about the performance, but if you'd like to hear us bragging about our performance, I'm more than happy to talk about performance on Slack. Storage. Our storage offering is fairly simple. We offer local NVMe, block volumes, file service, and object storage. Pretty much the same as any other cloud provider. NVMe is local to a bare metal server or virtual machine. It's non-resilient, so if you terminate your machine, you will lose the data on your NVMe. So if you need it to be persistent, you should back it up to block volumes. Block volumes are resilient. They can be detached and attached to between the instances. They're perfect for distributed systems. You get scalable size and performance. You have a little slider when you can change the performance of your volume depending on your need. We do also offer a fairly unique feature of attaching a single block volume to multiple instances at the same time, which is perfect for building a resilient, high-performing parallel file systems. Object storage, there is not much to explain. It's a traditional object storage. You get API access. We are as well S3 compatible. So if your application has been written with S3 in mind to retrieve data, you can do that on Oracle Cloud as well. We do offer two tiers, standard and archive. You can archive your data for the long-term storage and pay little if you don't need data to be accessed frequently. And the file service is basically a NFS mount point that you get, which is virtually unlimited storage, very easy to use. and can be used to store your applications or data. For NVMe, we do offer 4 shapes right now, or 4 shape types right now. So bare metal HPC2 with 1.6 terabyte disk, optimized 336 with 3.4 terabyte disk, and what we call a dense shapes. These are Intel-based shapes, and they are coming with 50 terabytes disk in bare metal offering and up to 25 terabytes per virtual machine. Block volumes. Block volumes are network attached storage, right? They are basically network attached LAN. They provide consistent and high performance. They're persistent, durable, automatically backed up into multiple locations. And you can configure your additional backup policies as you want. You can attach up to 32 block volumes per instance, and they can go up to 32 terabytes in size per volume. The minimum is 50 gig. So you can attach up to 1 petabyte of storage per instance. They are for bare metal offering. They are iSCSI mounted devices. It's easy to use. It's pretty much what you would do in your data center. Most people understand how it works. But for virtual machines, they also come as para-virtualized or emulated attachments. You do sacrifice a little bit of performance for easy of use. We do offer multiple tiers of performance for our block storage, from lower cost, where you can get up to 480 megabytes per volume. It's our cheapest storage. You don't buy any performance units for that. It's if you don't need performance, you just need a lot of storage. It's a perfect solution. Balanced is our default tier with 480 megabytes per volume, with 25,000 IOPS per volume at the size. One thing to mention is performance goes up with the size of the volume. So we provide a certain amount of IOPS and certain amount of megabytes per second based on per gigabyte. Maximum performance is usually achieved at around 700 gigabyte volume, and then it doesn't scale any further. If you need to scale your performance further, you can attach multiple volumes. But we can go to higher performance with 680 or lower ultra high performance volumes with 880 megabytes per second. But our top tier offering is full ultra high performance volume with 2,680 megabytes per second performance and 300,000 IOPS per second. I don't think that anybody else has volumes that fast attachable in the cloud. FSS, so file system, file storage service. It is a managed service. You click to get the file system service. You pay as you go. You pay only for what you store. You don't pay for the service itself. So you pay per gigabyte of stored data. It is an FSv3 based file system. We do offer some options of configuring mount options depending on the source IPs that will be accessing the file system. You can configure read-only or read-write policies for mounting the file system. It is made for general workloads that need shared or distributed file system. It has a fairly consistent performance at around 600 megabytes a second read-write speed. If you need more, you can attach more mount points and distribute your mounting on your virtual machines between these. We are looking into increasing the performance, but right now 600 megabytes a second is the official number that we support. And a little bit about the external connectivity. If you need non-public access to your environment, we do offer a VPN service, which is an IPsec. It supports dynamic routing. You can run BGP over IPsec and the policy and route-based configuration. For most of our customers that are running large workloads and they have large amounts of data, we do offer better option, which is Fast Connect. It's a dedicated connection, similar to what other cloud providers offer. You get a port. It's 1 to 10 gigabit a second. What is new here is you pay only for port. So it's a standard month. It's the same monthly charge, and you don't pay anything for ingress or egress, which for moving a large amount of data can be non-trivial cost. Okay, so just as a reminder, we offer both VMs and bare metal servers, GPUs. You can deploy high-performance file systems. We do offer automation for deploying BGFS, Lustre, cluster, spectrum scale with throughput at around 140 gigabytes a second. High-performance networking, 250 gigabit network interfaces on the regular shapes, and 100 gigabit networking for RDMA, and up to 1 petabyte of storage per instance. Okay, talking about the automation, we usually offer 3 ways for our automated solutions. One is Oracle Cloud Marketplace. You can go to the website, click on search whatever you want, let's say HPC, and find solutions that are made for HPC. You can use command line interface to deploy integrations with the workflows and stacks, and resource manager stacks. These are Terraform-based infrastructure as a code solutions that are also powering most of our marketplace offer. So what we offer for HPC automation? We do have OCI HPC, which is our stack available on GitHub. It's open source project. It's Terraform and Ansible based. It has a graphical wizard for configuration, and it can be deployed in a couple minutes. You will get your HPC environment ready to run your workloads. I've actually started this project early 2019. It is my pet project. It is my baby, and I'm really proud where we have taken it so far. And we are more than happy to accept pull requests and see forks from customers, see how they are using it and what can we do to improve it. It is also available on the marketplace. If you look for HPC in Oracle Cloud Marketplace, you can find it and deploy it with 1 click. Another solution is OCI HPC file systems. It's a single-click solution to deploy apparel file systems. And these are really high-performing things, and the results that you might see on IO 500 list has been done with exactly this solution by a colleague of mine. We also offer what we call an easy HPC, which is a simple command line interface to deploy HPC clusters. It actually uses either OCI HPC or HPC file system stacks in the background to deploy things based on a simple configuration file and the CLI command. One thing to add actually about Easy HPC contains also a few minor customizations on top where you can, for example, deploy OpenFOAM automatically. And it contains a database of applications that you can use to customize on top of the cluster that you're deploying. So this is a diagram of our typical cluster deployment. If you deploy it from Marketplace, we deploy a VCN, which is a virtual cloud network. with 3 subnets: a public, private, and what we call an additional subnet. The public subnet contains the Bastion host, which also acts as scheduler. If you choose to deploy a scheduler automatically, it acts as a login node for your cluster. In private subnet, we deploy the compute. It's not accessible by default from the internet. You have to go through the Bastion to access your compute nodes for security. And in additional subnet, we leave this subnet empty if you want to deploy, for example, an HPC FS into that subnet. It's absolutely supported, and you can connect all the elements together to build your high-performance computing environment. By default, we do export multiple file systems, multiple shared mount points between the nodes inside the cluster. /home is shared across the cluster from the Bastion. We also export NFS/NFS/cluster as a storage space for any kind of small files that you might want to use, exchange between the nodes easily in a more public manner than your home directory. And if you choose to deploy a persistent cluster, you can also deploy what we call NFS Scratch, which is exported from the NVMe drives of the compute nodes. This way you get MPI checkpointing location that has a huge amount of IOPS without having to deploy any additional file system if your workload doesn't require it. Again, it's open source. It's available on Marketplace and GitHub. It's fully open, no strange technologies. It's Terraform, which is open source, and Ansible, which is open source. We offer graphical wizard, API and CLI deployments. You can configure a lot of storage options, choose your performance, the size of the volumes that you'd like to attach. We offer autoscaling with Slurm or PBS Professional. The cluster also comes with a little LDAP server if you want to have a multi-user environment automatically. Users can log in with the LDAP credentials from the Bastion host. We do offer automatic SPAC installation for the cluster, a little monitoring portal. And if you run on Oracle Cloud and run Oracle Linux, you also get free K-Splice for live patching, which is pretty cool, where you can update your system, update your kernel, update your kernel modules without having to ever reboot your system. On the left side, we can see the example of the console menu that can be used to deploy, where you can select your shape and location of the cluster. And at the bottom of the screen, there is a little informational field, how it looks when it's deployed. You will see your Bastion server public IP, to which you can SSH, and the private IPs of your persistent cluster if you have decided to deploy one. Autoscaling. For autoscaling, we have multiple configurations, and you can configure actually multiple queues in both Slurm and PBS. You can configure multiple available shapes per queue. For each of the shapes, you can configure limits for the users or for protection from extra charges. And you can say how many virtual machines or bare metal hosts you're allowing the cluster to operate at the time, and how many clusters would you like to operate. We do support all the shapes, including all the RDMA shapes, ARM, GPU, and Flex configurations, as well as standard virtual machines. And we support both persistent environment and the bursting for autoscaling. Our approach to autoscaling is based in a way of cluster per job. we do not scale your single cluster up and down. If the user submits the job and says, hey, I need 72 cores of bare metal, we will spin this little cluster for this particular job, submit the job to this cluster, and when the job is finished, we'll wait a minute if the user decides to submit another one, and terminate the cluster after it's done. You can see a little monitoring tool that we have using Grafana. You can see how many clusters are being provisioned at the time. You can see your current node utilization and things like that. The whole process is done through a script that it's monitoring scheduler queues. We look if there is a waiting job. If there's a waiting job, we look at the constraints of the job to decide what needs to be created. Terraform creates infrastructure for the new cluster, and we use Ansible to configure the cluster according to the specification that you have selected when you deploy the cluster for the first time. There is also a configuration file where you can say that specific shapes will use, for example, a different image from the one you have selected. So you could actually run a certain jobs on Ubuntu and certain jobs on Oracle Linux and just like that. Nissan is one of our customers that uses our automation tools. It's a great story for us and for the customer. We have built this scalable solution, which is both high performing and cost effective. For them, they're running complex crash and CFD simulations on Oracle Cloud in a fully scalable way, operating the cluster automatically without human intervention. Users can submit their jobs and they get capacity on demand for their jobs. They're running a lot of latency sensitive workloads, and we use a lot of RDMA clusters for those jobs. They're also running a VDI solution to do post-processing directly on Oracle Cloud. Okay, I'll switch to a quick demo. I'll show you a little bit of cluster configuration, how we submit the job, and how the autoscaling interface looks like, and a monitoring tool that we can see what is happening on the system. Zoom is not cooperative, but here we are. To save time, I've obviously deployed a demo environment, so we don't have to wait for the deployment, but I'll show you how it looks. So this is what we call a stack, and this is the configuration for an automated deployment. We can click on Edit and run the configuration menus. We have a concept of compartments which separate users or groups from each other, and they can deploy resources in their compartments and the bill separately in their environments. Most of the menus here are pretty simple. You upload your SSH key. We can either create an automatically name, or you can create your own. You can deploy the LDAP server and decide where you want to deploy your solution. What shape would you like to use for the Bastion hosts, and you can configure some additional options depending on your need. For compute, you can select either to use cluster network, which will be an RDMA network. For this, we only support HPC2, GPU4, and optimized 3 shapes, but you can also operate persistent cluster on any shape you want. You can also set the initial cluster size to 0. We will only deploy a bastion host for you, and you can use auto-scaling without persistent environment to run your jobs. You have option to keep SMT disabled or enabled, depending on your need. We don't see that much difference actually with disabling hyperthreading. And you can choose either a predefined images from our list, or you can use any image from available images, or custom image if you have created one. Authentication for the Bastion host to operate the cloud. You can deploy additional file system. You can create FSS or mount existing FSS if you have pre-created one. A lot of customers do it like that. They create an FSS, load their applications to it, and then just enter the NFS server IP to mount. You can create either a new network or use existing network to deploy the cluster. And by default, we offer Slurm installation automatically. So you can choose to install Slurm, name your queue, and install additional tools. After the cluster is deployed, we can see the apply process and the full deployment log here, and look at the application information window to log in to our host. So let's take a look at the logging to the system. Our default username is OPC. It's coming from Oracle Public Cloud, and we are on the Bastion host. I will re-log in and create some SSH tunnel for our monitoring, and all the configuration menu, all the configuration files and example batch scripts are in OPT OCI HPC Autoscaling. We have a queues configuration file, which you can use to define scheduler queues and shapes and all the little variables that you will use to deploy those clusters. And you will use the name of what you have created here. So for example, VM standard 2.4 name as the constraint in a job submission script. So we can look at the sleep-vm sbatch, simple submission script that just sleeps. What we are doing here, we will ask for 2 nodes of VM standard 2.4 and 2 nodes. And we say cluster size 2. We can omit this, or we can use this to control the minimum size of the cluster to be deployed. This helps sometimes to more tightly pack the jobs and be able to hit the clusters before they are terminated. So we can submit our job. We have 2 nodes, they're both free. We can submit our job. And here it is. It's waiting in the queue. There is no resources available for the job. And we can look into the logs directory, which contains a cron-top slurm log, which is basically our cron-top script that monitors the queue. Very simple tool. And you can take a look at the log file here to see, is it currently creating any cluster? Is it destroying any cluster? What is it doing? For each of the new clusters that are being created, each one is logged here. So we can see the build process and what exactly is happening, especially if you have any problem. So we can look here, and we had a cluster asset and all the output from our build process here. So we can say that it was successfully deployed. As you can see, it's Terraform, and the Ansible process completed successfully. No failures here. Cluster was deployed, and our resources are available. We can take a look. We can see that we are building nodes of 2 nodes of VM standard 2.4. All the output is easily parsable with JQ. And we can also take a look at our Grafana to take a look at what is happening here. By default, user admin, password admin, available on the local port 3000. And we can take a look at our dashboards. We usually have 2 dashboards available, a cluster dashboard, which monitors the resources and the CPU usage and memory usage and things like that. And the autoscaling dashboard that tells you exactly what is happening in your autoscaling system, how many nodes are being provisioned, how many nodes are being deleted, what is our node history, so we can see, for example, last 24 hours, and you can see I've been testing the demo cluster before. You can see I've been provisioning some nodes and then they were destroyed automatically. You can see the current information about what is being created, how long it takes to create, and to which job they are assigned. Okay, more than happy to answer any questions live or answer them on Slack after the presentation.
Right. So thank you very much for your talk, Marcin. So we do have a few questions on Slack. So I can start with those. I can ask you here, if that's okay.
Yes, absolutely.
Sure. So the first question is from Dr. Hari Subramani, and he's asking any reason why Oracle chose Rocky version 2 over version 1?
Yes, due to the way that the network is built and for the scale that we are building the network, we believe that the routable Rocky is the more scalable solution and more future-proof than running pure Ethernet.
Okay, okay. And another related question is, why not native InfiniBand?
The answer is, the answers are two, actually, to this question. One very obvious is cost. InfiniBand solutions are expensive, and we wouldn't be able to offer InfiniBand at the price that we can offer Rocky at. And we do not see many benefits of InfiniBand, especially in the cloud-based environments at scale that the most cloud-based workloads are running, to run InfiniBand. Yeah, there's and we believe that Rocky is actually the future, and it's due to its cost effectiveness and still amazing performance. We believe this is we made the right choice here.
Okay, okay. Hari, do you have a follow-up question on that?
No.
Okay, thank you. So we have another question by Shule. And Shule asks, so OCI HPC image provides necessary libraries for HPC application users, but users cannot export the OCI HPC image for purpose of sharing or making backups. So are there any alternate scripts or tutorial documents that people can use that will let them install these necessary libraries like RDMA, OFFID, or others?
Yes, so this is a non-issue. We do actually allow creating a custom image out of the marketplace offering. But current limitation is you cannot export it to an object storage to share it with others or move it to another region. But to be honest, there are two solutions to that. One is we're working on making our image building repository public. This is one thing. So you will be actually able to use the same scripts that we're using to build those marketplace images in your own environment, to build your custom image with whatever you want. The other thing is we might be able to offer exportable images in the near future. And by near future, I mean probably Q1 2022. The images might be exportable. There is a third solution, is called shoot us an email, send us an email, or over GitHub, or my email will be available, and we'll just give you a file with the direct link to the image that you can download and use it. In general, there are only two things that are really required to operate an image on Oracle Cloud. One is an OFED, and you can either run inbox drivers, or for better performance, you can run Mellanox OFED distribution. We suggest running 5.0 at the moment. This is what we're testing, and this is what we stand for. And the other thing is, there is a little tool required for network authentication due to the network separation layer between the users for Ethernet. There is a little tool. There is a GitHub repository. I'll send the link on Slack as well for this little RPM package that can be installed to automatically provide the authentication to the network. And those are two things that are really required. You can take any CentOS or Oracle Linux image from our platform images and build your own.
Sure. Okay. Thanks for the detailed answer. Really appreciate that. There is also another question. So do users get an entire node when they're provisioning, let's say, VMs, or are these shared nodes? Are any cores on the node reserved for running the hypervisor?
There are a few cores reserved for the hypervisor, I believe. So when you run a virtual machine, you are sharing the environment. Unless you're running dedicated virtual machine host, then I believe there are a few cores reserved for the hypervisor. So if you run, let's say, a 52-core bare metal machine, I think you can use up to like 48 cores. You can, anyway, the 224 for standard machines is the maximum VM size. So I think the virtual machines are sized in a way that you can pretty much put the two largest virtual machines on a single bare metal host.
Sure. Okay. Okay. So what kind of container support exists on OCI today?
So for container support, it depends. We do offer cloud native OKE service, which is a Kubernetes as a service. We give you the master, and you just say how many worker nodes you want, and we just run it for you. It's auto-scaling. It's a really neat solution, and it supports obviously a Docker-based containers as a runtime. For HPC clusters, we are running pretty much everything that it's there. We run Docker, we run Singularity. For NVIDIA workloads, we run En-route for the deep learning. We expose the Mellanox devices to the containers and run distributed workloads with the containers as well.
Sure. Okay. Okay.
And
so,
I'm actually writing. Thank you for a reminder. I'm about to write a guide on running distributed container workloads on Oracle Cloud.
Sure. Okay. Yeah. So thanks a lot. Thanks. This was very useful session. We learned a lot, and thanks for your detailed answers as well. So
thank you very much.
Yeah. So attendees, if you have any questions, any other questions, kindly, you can contact Marcin on the Slack channel, please. So with this, we'll, thank you again, Marcin. Thanks a lot.